Hi, I'm Craig Kundrat, the Director of NASA's Space, Life and Physical Sciences Research and Applications Division. Our work in the division focuses on enabling human spaceflight exploration and pioneering scientific discovery. What is combustion science, and why do we study it in spaceflight?
Well, if you think about it in application format, there's really sort of three big classes. There's fire and its prevention, and then there's power generation, and then there's heat and propulsion. Why do we want to study these things? 85% of our delivered energy, even now, with all the advances, still comes from burning fuels. And so with planes, trains, automobiles, ultimately the power goes back to combustion. The other side is fire, and fire is a catastrophic hazard for our space flight. And so we need to continue to improve our understanding of fire, and so we can mitigate its risk. BAS in particular will give us information about the fundamental processes of flame spread and flammability and combustion of solid materials.
What materials are we studying in space, and how do they differ in their flammability compared to what we have on Earth?
The materials do burn very differently in space. Some materials melt when they burn, and the melting materials in 1G will drip on Earth, and the dripping takes the energy away from the fuel, whereas in space that dripping doesn't occur. And so you get this accumulation of the molten material, which increases the fire risk because you've got all this hot, flammable fuel ready to go. Clearly, you can't just set a fire anywhere on the space station. So it's important to do it in a safe environment. So we had a very small flow duct, probably about the size of a loaf of bread. And then we put that flow duct inside another larger experiment rack, which was called the Microgravity Science Glove Box. And the crew could only access that through glove ports. And so they really weren't exposed to the flame at all.
So Gary Ruff, you undertook a larger enterprise. Can you tell us about that?
Sure. The Sapphire set of experiments, or spacecraft fire experiments, finally gave us the chance to study some large-scale fires, things that would have more fuel and more surface area. We really didn't know how large the flame would grow. One of the findings was that it very quickly reached a steady state. The spread rate was quite a bit slower. Really, the flame length was a little bit smaller than what I certainly anticipated. Sapphire was about 40 centimeters wide by almost a meter long. And so we would burn that whole sample in one experiment. Sapphire provides the large scale.
So have there been any really unexpected results?
On a RITSI experiment we did back in the 90s, we were planning to study a smoldering piece of fabric, and we were igniting it at a spot, and we were expecting to see this circular growth out from that. But what happened is, instead of having a nice uniform ring, the flame broke up into tiny little spots, like smolder spots, and then they started propagating outward like little bugs crawling everywhere. It was just so freaky looking, and we had totally not expected that. And later we were able to make lots of measurements from that and come up with some really good theories to explain that, but it certainly was not an expected finding.
Wow. What are future directions for combustion research based on what we've seen so far?
Well, we're continuing pursuing the surprise area we had in low temperature chemistry, and then we're following on in the SERV, we're going to be doing gaseous flames, and then following that we're going to be doing solid fuel experiments in the same facility. We'll be doing more testing in the Sapphire environment.
We've got 5 principal investigators lined up to use the solid fuel insert, and each investigator is studying some aspect of flame spread, flammability, or ignition processes.
For Sapphire, I mean, our future and what we're looking for is just to make bigger fires. And we want to see how those types of bigger fires then interact with the vehicle and what effects it has there, so that we can provide the right equipment to protect the crew.
Thank you, David Urban, Sandra Olson, Gary Ruff, for this briefing on combustion science and a look ahead to the future. For more information on the future of combustion research at NASA, please see the URL on this screen.